All right, so you're back. All right, so we're up to question 11. Calculate the total time of flight in the ball. We've done that before. Remember? We did that before. We did, okay. So let's take a look. How did we do that? Well, we know that the final velocity y is equal to the initial velocity y minus g times t. Aha! So basically, you know that the time is equal to 2 times the velocity in the y direction, the magnitude of it, 2 times velocity in the y, divided by 9.8. That gives you your hang time. So for the Aaron Judge problem, our hang time, the time, this is a hang time thing. So we've got 2 times 22.2 divided by 9.8. Whoa, is up there in the air, 4.5 seconds. Okay? All right, now, so for 12, then the range. So now that you know the time of flight, calculate how far the ball would have traveled under ideal conditions. In other words, in the classroom. In our classroom, we'd say, oh, okay, so now we've got to go back to V naught x, which we computed as 43.3 meters per second times this time, and that'll equal our range, which is equal to 43.3 times 4.5. And that equals 190, basically 195 meters. Let's convert that 195 meters into feet real quick. I'm going to do that right here. (195 meters to feet). 639 feet. 639, or basically about 640 feet. I'll tell you what, right now, the furthest anybody can hit a baseball is less than 500 feet. So that's our undergrad. Convert your answers to feet. Okay. So how far did our ball travel? On our question 11, it'd be 195 meters. Okay. Well, the time is total time. 12 is this. 13 is the 640 feet that we just did. All right. And then 14 is, now the ball actually, this ball actually traveled 454 feet, right? Or 452 feet. So to calculate the Reynolds factor, all right, so 14. Now watch this. This is pretty cool. In fluid dynamics and areas of fluid, we've got a thing called the Reynolds factor. This is really high fluid. This is high level, like hydro dam stuff, you know, fluid mechanics, Stokes theorem, things like that. This is complicated stuff, but we're just trying to find a simple number here. It's a factor. We're going to find the Reynolds factor for this home run, and all the Reynolds factor is how far it actually went, real distance divided by schoolhouse distance. That's all it is. So for our Aaron Judge problem, we're going to take 452 divided by 640. And we come up with a thermodynamic number of 0.706. And it's just a number. All right, and so that's how you calculate the Reynolds factor. Okay, clear as mud on how to do this lesson. I think you're going to be great. It's not easy, but it's not. Wow your friends that have not taken any physics or anything like that with what you're learning, and show them, hey, look what I have to do, and they'll be like, whoa, you can do that? Of course you can do it. You know why? Because you're smart. All right, so out here we are done. Oh, forgot to hit that. There we go.